So welcome everybody. Good evening, and thank you for having me, especially on a weekend. And glad to be here at the Pune Tech Community Platform. Very active in organizing AI events and other events as well, right? So guys, keep up the good work. Let us begin with our topic today, which is ML at the edge, especially related to vision analytics with digital twin. All right. So this is about me. Can connect with me on my LinkedIn or my Twitter handle, which is at FuzzyMind1. So the agenda today will be something like, first we will check about industry view on data and AI, because typically, vision analytics and edge learning, edge ML comes in play, especially when it is in viewed in conjunction with manufacturing, right? Then we will look at digital twin, what is so special about it, and energy analytics examples, demos, and stuff. All right. So before we go on, right, why we typically are concerned about edge. So when I'm saying machine learning at the edge and digital twin and all of this edge computing, so what is this edge and where is it located and how is it different from our Internet of Things, right? So we have our smart homes and our Alexas and our Siris and our Hello Googles, right? So those are all Internet of Things and connected world and smart assistants. So what is it specially with edge, and where is this edge located, right? So the issue, what happens is, when we talk of Internet of Things, typically, which are smart devices which will transmit the data and have computation done, analytics done, but in the cloud. So which means what happens is these all your smart assistants, or your smart devices, right? They need the internet connectivity for having this sort of a for transmitting data into the cloud and then getting this analytic capabilities, right? So when we talk of edge computing, edge computing is when you're disconnected from the internet. You might not have an internet active internet connection, and these IoT devices which are transmitting the data should be able to do the analytics within the device itself without relying on the cloud, right? Without relying on cloud analytics. So that is called as edge computing. And now, why edge computing is because typically, if you see, right, especially in a manufacturing scenario, imagine that your production line there's a sensor installed, or camera, or a sensor, or some type of an RFID scanner installed on your production line where your products are actually moving. There is assembly, and there is a welding, and there is packaging, and all of these things real time. Now, whenever there is probably some worker is coming very near to some danger area, some restricted security area, and you immediately want to raise an alert and stop the production line before any further damage can be caused. Or you see that there is a fault in the packaging and you want to immediately stop the line itself, without letting it trickle for the next 4-5 bottles or products. So in this for the data to be transmitted to the cloud, send it back, some sort of intelligence, right? Like, hey, okay, this is too near to the machine or dangerous area, so stop the production line. Or packaging is going wrong, stop the production line. The humidity levels are high, stop the production line. So this kind of analytics, if we are relying on that internet connectivity and is done in the cloud, it could cause some sort of latency, and the impact may not be instantaneous, and we want like instantaneous feedback here. So which means we need to be able to do this machine learning, this sort of computing in the device itself. So the device, our AI workloads or our machine learning workloads should be able to be deployed on the device itself, and then the whatever data is being transmitted from the device, and that machine learning workload on the device should be able to take decisions and then indicate the corresponding action. Okay, so sometimes for mission critical things, for example security, safety, these kind of things, edge computing is really really important, right? So edge computing basically means the devices which you have, your smart assistants, vision cameras, CCTV cameras, but they have this computation enabled inside them instead of relying on internet connectivity and cloud to do this computation analytics for them. That's the only difference, right? So just imagine edge is IoT, edge is a computational power imparted inside the device itself. Okay, so this is what we said, right? So role of ML at the edge, right? So ML at the edge, it can be used to help certain edge devices to understand and make predictions based on the data they store and process, right? Some sort of alerts can be given, some sort of I will show you a real time demo where, let's say, there's a faulty shipment, and we can make predictions about what would happen and what would be the potential loss if this temperature and humidity condition for the faulty shipment continue to persist, and rolling implications of that towards factory outlets and consumers and all of those. Okay, so it can predict the next input based on the previous one, right? So previous now, for example, your production line, your processing is done, then your assembly is done. So what is the next best action, or what is the next best routing mechanism? So all of these machine learning at the edge things, predictive analytics, and part maintenance, predictive part maintenance, these we will see in our session today. So a lot of demos, a lot of interactive videos. Okay, and this is what I was talking of, right? Edge AI. So your AI workloads, your machine learning, and all of your intelligence, which is now sitting on the device itself, which is called as the network's edge, and this is called edge AI. Now, edge AI might require you to have certain sophistications inside the device itself, because let's say, for example, typically your vision algorithms, your object detection, image recognition, the models itself are quite heavy, right? So they are okay to be deployed on. So imagine, like, the vision analytics is, the models are trained on GPU clusters, GPU machines, right? And then that heavy model probably sometimes running up to more than a few gigabytes, that model you have to deploy on a small edge device, and it should be able to make decisions. This is where your sophistication comes in, where you have to now fine tune, or you have to sort of restrict the model's footprint to fit to that edge device. So there are many edge sorry state of the art technologies here for ML edge, which is, there's something called as DECI. So that helps you to gives you optimizations to be done to your model, so that it can now fit the memory footprint of that small device. Or you have something called as tiny ML, which is ML at the edge. So ML algorithms and models that can be fine tuned to fit the edge devices, right? So because typically edge devices use CCTV cameras and your wearables and your AR VR devices, they will not have a lot of memory. Definitely not to the tune of gigabytes and all, which is required to run these kind of vision models, especially, right? Vision models, deep learning models. So then this is all the next generation of edge AI technologies which will come into picture, and probably not a session content for today's session. So yeah, so just probably, if we want to deep dive into ML at the edge at some later point of time with all the algorithms and memory optimizations, we can reserve it for a separate session. But today it's more of ML and digital twins, right? So before we move on to digital twins, I want to show you that why manufacturing industry is more often the contender for digital twins, right? So because if you see it, in the industry, right, it is the forgotten sector, correct? So industry sector has almost been entirely ignored, even when it comes to the climate sustainability factor. Productivity stalled, and most of the initiatives for manufacturing, they they start and die at the pilot stage itself. Okay, so pilot purgatories, which means most of the manufacturing stuff, if we talk of smart factories and intelligent IoT and all of that. So as you can see, industry 4.0 was defined in 2011, and IoT investment accelerated in 2015, AI in 2016. But still 10 years later, smart factory still remains an aspiration. And I actually see that, right? I mean, even for huge beverage giants like Coca-Cola and all, they still are struggling to achieve at this to arrive at the smart factory paradigm. Okay, and why is it? Why is it that? Because what we see as an ideal, software stack, So for example, this is connectivity, data storage, visualization, analytics, AI, ML. But for a manufacturing industry, this is what it actually looks like. So this is the expectation versus the reality. So each of the manufacturing systems, right, logistics, maintenance, management, production, admin systems, each of them have a different tech stack. Okay, some could be modernized, some could be totally legacy, some even don't have the IoT devices enablement infra inside them. Like, what are IoT devices? How do I connect them to my production lines, right? So probably like logistics or your quality management systems could be a bit modernized, but then most of your tracking systems and shipment and all of that is very, very legacy, and all of these are residing in different silos, right? So they cannot be streamlined so easily. And compounding the problem happens is because what you define as a machine, right? So from a digital twin perspective, okay, a small rotatory fan or a turbine could be an engine, could be a machine, sorry. The entire shop floor comprising of various machines could be altogether a machine. So it is very difficult for me to define and represent a machine and achieve analytics for that. So probably if I, if I do track, or if I do optimize one particular machine, right, in this entire shop floor, it can be as small as one turbine of a particular engine, right? Or it could be so many set of different machines operating in tandem to achieve one production process here. So a lot of different possibilities, and that compounds the problem. Okay, so which so much, heterogeneity, how do we succeed? We succeed by standardizing the data. So all of these different systems, right, so they will stream the data and we will standardize them, and then we will build up digital twins from the standardized data using the common data models, and then we will do the analytics. So instead of inherently changing the systems and taking eons of or ages of time to do that, what we do is, whatever your data, stream it, whatever shape or form, stream it. Probably, there could be real time data, there could be your legacy system streaming data, your machines, IoT sensors installed on the machine streaming real time data, vision data, RFID scanners, GPS, whatever data you stream it, we will standardize it, we will build a real time digital twin, and then we will enable analytics, right? So we will standardize the data for you and we will do the analytics, and this is where digital twin comes into picture. So you have connect, transform, analyze, build, and we will share the results. So results could be in the form of dashboards, result could be in the form of alerts, results could be in the form of some intelligence. Okay, and we identify process engineers, operators, data scientists, connected machine sales teams, economists. So all across the manufacturing ecosystem, various users will be covered by our solution, or whatever manufacturing AI we talk of. Okay. So when we talk of manufacturing value proposition, we talk of workforce empowerment, obviously, right? Resilience meaning your willingness to change and embrace the next challenge, and organizational agility. Agility meaning, your susceptibility and your willingness to thrive in a changing environment, and then your support for innovative production, sustainable and innovative production. So this is what is targeted by your industry 4.0 and your smart IoT, okay, smart factory. So before we move on to all of these workforce empowerment and operational resilience and organizational agility, and we deep dive into just jargons, I want to make this easier for you by showing how digital twin really enables an end-to-end smart factory. Okay, and this is done real time by Microsoft. I'm going to stop sharing, and I'm sharing again with the computer sound so that it is easier for you to comprehend what I'm talking about. So let me share back my screen, and here we go. Yeah, right. So let us look at the factory of the future, and all of these, how it is achieved with the help of digital twin. Okay, I'm going to start.
I'm sorry, I can't hear anything.
Sorry,
There's no sound in your video.
I just thought I shared my sound. Okay, let me check. Stop sharing. Share. Include computer sound. Oh, okay.
No
Sorry.
problem.
I didn't include. Okay, sorry. Let me. It's only 43 seconds. Okay, fine.
Yes.
Let me start again.
With more than 200
Perfect.
breweries
Thank
Now
you.
and
is it okay? Oh, okay.
Yes. Thank you.
160,000 employees across the globe, Anheuser-Busch InBev is the largest brewer in the world, with an unparalleled portfolio of brands and a global presence with operations in 50 markets. AB InBev is an expert in their field, and their forward-leaning and innovative spirit is leading to new breakthroughs in brewing. Through their digital factory and supply chain of the future initiatives, in collaboration with Microsoft, AB InBev is focused on transforming both breweries and their global operations by empowering their frontline colleagues with digital solutions that enable world-class manufacturing, mobility, data automation, and business insights. It begins with the brewery coming to life with AI, Azure Digital Twins, and the Microsoft Cloud. The brewmaster is responsible for making the best quality beer. She has unprecedented visibility into the brewing process, so she can predict and monitor the complex chemical and biological fermentation parameters required to produce the highest quality product. Frontline operations can remotely monitor critical quality and traceability data from the manufacturing execution systems using the mobile brewery technology built using Azure. With built-in energy and utility management solutions, the digital brewery supports AB InBev's industry-leading sustainable development goals. After the perfect batch is ready to be bottled and shipped, AB InBev extends their digital twin solution to support the packaging line operations to ensure it's done right. These CAN plans are adopting Azure AI and Microsoft Project Bonsai's deep reinforcement learning to deliver line balancing optimization that detects and automatically compensates for bottlenecks in the complex can manufacturing operations. At AB InBev, their 100% uptime mindset is enabled through predictive maintenance and global support. A frontline operator can efficiently address problems through remote collaboration with a maintenance technician, ensuring no unplanned downtime of packaging equipment. The perfect beer is packaged and ready. The digital technologies of the AB InBev supply chain of the future minimize this carbon footprint while making sure the right beer gets to the right customer at the right time. This beer's journey is complete, and AB InBev and Microsoft are taking bold steps into the future.
All right. So I hope that was inspiring. At least every time I watch the video, I am in awe of what could be and what are the future possibilities with the digital twin and Azure IoT and smart manufacturing, right? So as you see, when I talk of connected ecosystem is right from your raw material procurement to your manufacturing processes to your packaging to your delivery to your end users. All of that is a connected ecosystem at each and every point. So all of your stakeholders are always connected, and you are able to make smart decisions and have sustainable processes, have optimizations, have predictive maintenance, and overall have this sustainable journey. So not only sustainable for your from an energy or emissions point of view, but also sustainable in the terms of your profits, right? So a lot of these value propositions come in the form of energy savings, cost reductions, processes uptime, manufacturing, better uptime for your machines, better product yield, better scrap management, scrap disposal, better waste management, right? I'll give you certain examples in real time also. I mean, AB and Bev being one of the most famous ones and one of the the much advertised ones. But yeah, I'll give you some certain smaller brand names also where they have implemented these kind of machine learning and digital twin with help of edge analytics and taken bold steps into the future, right? So as you can see, manufacturing all up. So building more agile factories, creating more resilient supply chains, and transforming your workforce. Okay. So when I say agile factories, meaning, your readiness for change and your readiness to predict change. So how do I proactively, monitor my machines for their maintenance, right? So I can better manage my machines. I can increase their shelf life. So predictive maintenance, predictive part maintenance, especially in manufacturing, right? Which is, let us take an example of oil and gas, and where you have those oil drills and all. So if I'm able to do predictive maintenance of those parts, those pipes, those machinery, turbines, and all of that, definitely I'm going to save a lot of surprises at the last minute, and then definitely I'm going to increase the shelf life and the optimization of all my production processes as well, right? So these are some of the brands, as you can see, doing all of that. Not only predictive maintenance, automated quality inspection. And I can, quote a very beautiful example here. So automated quality inspection is, you have, your diagrams of your processes, right? So we call it in manufacturing as your process engineering diagrams. So let's say you have a diagram of a particular oil drill part, and let's say the rule says that, I mean, the quality rule says that if this particular pipe has an atmospheric pressure of 1000 kPa, then it should have a double block valve. And that drawing gets passed, or that pipe part is passing through some, vision camera for inspection. Then the AI can detect and understand that what type of pipe is this, what type of valve is this. It can convert that instruction into a machine learning instruction and do the quality inspection and give the result as a part is passed or rejected, passed or, accepted or rejected. So this is automated quality inspection as well, enabled with the help of digital twins and IoT and vision analytics, right? You have supply chain optimization, as we saw, like right from your procurement of raw materials to your shipment to various modes of, your transportation, and how the final product reaches your end users, how sustainably it reaches your end users. So all of that entails supply chain optimization. Worker health and safety is, having your vision cameras, especially on construction sites, for example, to be tracking real time the movement of heavy machinery, workers and stuff, and see whether they are working, maintaining the relevant distance, and they are not directly under heavy machinery or dangerous positioning and all of that, right? remote Remote work and productivity, and process and workflow improvement. So like, probably, maintaining a control tower, and then having a central view of all your processes together. Okay, so these are some of the things, like how worker health and safety was done, or how logistics and planning also was done using digital twins, and collecting the data, sampling that. Okay, so GE Aviation, especially, right, Aviation's digital group, what happens is, when you're inspecting a flight, there are a lot of things to be inspected. I mean, there are your controls in your cockpit, which has to be monitored and checked, and there has to be all your other things, like your cabinets, your seats, and your life jackets, all of your inventory management, whether it is correct or not. So all of that has to be audited, and the report has to be submitted. So GE Aviation Digital Group, they went for digital twins for streamlining these kind of things, and streamlining the disparate systems, together, to give a holistic centralized reporting for their aircraft and its maintenance. Okay, so these are some of the other domains, right? So predictive maintenance, as I was talking of, like predict in advance of your parts and wear and tear and sort of that. Okay, so won't go repeat those things again, right? And now when we talk of all these things, right, so we saw the video, we saw how digital twin enables all of these beautiful things. So what is digital twin? Digital twin, very simply put, right, it is a digital replica of your physical attributes. Okay, so your physical what you can your physical manifestation, digital manifestation of your physical entity. Your physical entity could be a simple machine, your physical entity could be your entire facility, your physical entity could be your entire enterprise, your physical entity could be your supply chain. So the digital twin can be there at each and every point, as we saw in the case of AB and Bev. Okay, so in AB and Bev, they had a digital twin of the supply chain as well. They had the digital twin of their production line. They had the digital twin of their, at the enterprise level, they had a digital twin of their maintenance systems, so that they can make a connected ecosystem. And digital twin need not always mean that you have this fancy as 3D representations of all your machines, your facility. That is case specific. So if you really want to have a real time view into how your production lines are working, fair enough. But otherwise, having a real time view into your system, getting some sort of dashboards, reporting is still a digital twin, right? So how my data is working, how my what my data is doing, where my data is, real time analysis of that is also digital twin. Not at every point of time it has to be your fancy 3D manifestations and 3D diagrams of your facilities and machines. It is case specific. Okay, so what can digital twin do in not in manufacturing but in general, right? So savings, it will improve the asset utilization. So if you have a predictive maintenance in advance, your shelf life of the asset is improved. So improved asset utilization, increasing production volumes by detecting bottlenecks and inefficiencies in your processes, yield and quality improvement, reduction in waste, operations cost reduction. Of course, like if your processes are optimized, then your operations cost will reduce, and reduce emissions. So if your processes are optimized, then it will entail reductions in your emissions as well, right? So if we were to do an anatomy of an intelligent factory, what we do is discover the failing KPI. So what is not working for you? Then we install IoT to collect the data on those inefficient processes. Then we have analyze and recommendations for adjustments to be done, and then we scale up. Okay, so if needed, we also create a 3D digital visualization of the machine or the production line, and then make the enterprise ready for future scale. Okay, so this is how intelligent factory architecture looks like. You ingest data from a variety of your sources. So it could be OPS systems, vision cameras, IoT sensors, external sources, your machine related data, right? So machine related streaming data from your RFID scanners or your IoT automation gateways. And you have a gateway which will transmit the data to your Azure IoT hub. You can have digital twins optionally if you want to have replicas of your production lines. And then these are the kind of analysis you do. Hot analysis, your real-time analysis, okay, which is streaming analytics of your data. Warm analysis is operational, time series. We will also see, how warm analysis helps and what sort of time series data loading will help you make decisions. I will show you in one of the other demos. Cold analysis is for your operational and unstructured data, right? So are there any patterns? What kind of, for example, we had done one route optimization analytics. So soldiers are wearing your GPS tracking devices on their arms, okay, or wearables like HoloLens on their head, and then this territory coordinates, latitude, longitude, altitude. We are actually taking and doing analysis on whether they are on the correct track or whether they are near to their mothership territory or in the enemy territory. That kind of analytics of your unstructured data as well. And finally your AI modeling and operationalization to give you these kind of pattern analytics or as I said, like some sort of alerts, some sort of view into the future. And then you are doing exploration either by the help of your Power BI reporting. It could be the output could be then consumed by your dynamic field services, right? It could be some sort of support tickets due to inefficiencies in your production line. So a lot of downstream systems to consume your data, right? So your analytics data can be consumed by a variety of systems to give you a variety of outputs. So these are some of the digital twin reports which you are getting. So you can have an intelligent factory view, as I said, a 3D factory view. You can have KPIs, right? So for example, cycle time and productivity and turnaround time of your machine or the product yield at the end. You could also have speed. Okay, so what is the speed of my particular production line? What is the temperature and humidity at the recommendation. So these kind of KPI monitoring as well. So as you can see, digital twin can mean also these kind of dashboards and reporting, and not only. I mean, it doesn't only entail all these 3D visualizations at all times. Okay. So as I said, digital twin, it is at three different levels. It is first of all, at the very first level is a physical or engineering twin. Okay, so it creates a copy of your physical asset or space. So it could be my production line, it could be my small machine, it could be one particular process in my manufacturing. Okay, then is the operational twin. Okay, operational twin is across the value chain. You are building a digital twin, like I said, supply chain, your inventory management, and finally is the intelligent twin. So it is now contextualized through a semantic data layer. Okay, so now your physical twin, then your operational twin, and comes your enterprise level twin now. Okay, so now this will support your rapid scaling and automation as well. So at a machine level, the physical and engineering twin is at an asset or a machine level. Operational twin is at the next level of scaling. And intelligent twin is where now you have a connected ecosystem. So this is based on a database, this is based on a data lake, and this is now based on a knowledge graph. Okay, very powerful. So let me, show you one sort of this digital twin, what we have done with we are almost close to the time. So without much ado, let me, show you the digital twin, what we have done for a t-shirt manufacturing. So this is a sample demo, right? And I'm going to show you at each stage how this warm analysis, cold analysis, and this time series data is captured, and how we are having the digital twin at each and every point in time, right? So right from your raw material procurement, from your shipment to your tracking, your factory level, to right to your retailer outlets. Okay, so so as you can see, right, this is a t-shirt manufacturing firm, and let's see how digital twin and vision analytics helps enable a smart factory. Sound is, you are able to hear the sound, right?
Let's dive in. Here is a global view of the company, including its suppliers, manufacturers, transportation, warehouses, and retailers. By combining all the data and creating a digital replica of this customer, we get a real-time representation of the health of the overall supply chain. For example, if we want to look at the production in one of the factories in Europe, we can click on the factory and its key performance indicators are given, being able to view what's happening within this factory. The efficiency indicator tracks the overall energy consumption within the factory. The reliability metric would show if the factory ships on time, with good quality, and within budget.
So as you can see, right, I'm building the entire digital twin of the entire, ecosystem of my t-shirt manufacturing. So right from its supply chain to its manufacturing to its retail outlets. Okay. So here, when I click on one particular factory and see the metrics, this is also a type of reporting, and this is also what digital twin helps us to do. So I can actually go and look at some of the KPIs. So these are some of the parameters, some of the KPIs measures which we are calculating based on historic or real-time data, and then able to showcase this sort of a centralized reporting. Okay.
Open orders would let us see what the factory is working on. This digital replica also models other components. If I click into one of our shipments in the supply chain, we can see the status of the goods and transports, tracking each container's location, its temperature.
So now, as you can see, this is a real-time tracking, right? So the shipment, how it is arriving, which mode of transport. I'm covering all, the airways, waterways, roadways, and then I'm tracking certain key parameters. So status on time, what is the location, temperature, vibration, and this can enable me to predict what will be the quality of my product even before it arrives to my factory.
And humidity. The digital twin can quickly identify if a product will be damaged before it even arrives to the retailer. As we can see, this particular shipment is scheduled to arrive on time and is currently within the humidity levels we need to maintain the quality of the products in transit. In our global view, we can see an alert at one of the retailers. This retailer is having a problem with a t-shirt shipment in California. As the digital twin connects the overall supply chain and processes, we can click on the t-shirt product and immediately narrow down the supply chain for this.
See, this is the beauty of digital twin. As soon as I get an alert on some, inconsistencies or some quality issues in my product, I can isolate the supply chain and see which factory is affected, and from that factory, which other outlets are affected. Okay.
This specific t-shirt. Now, let's click into the factory where this product was manufactured and check the temperature and quality levels during the time the product was created. If they are off, this could be a major issue for existing clothes being produced. So let's see what's happening.
So now once I click inside the individual factory, now I come to the digital twin, which means the asset digital twin, right? So the digital twin of the production line itself. So the previous, the ecosystem which you saw that had just a representation of, tracking and dashboard reporting. Now, once we come inside the factory itself, you see now we have 3D replicas of the production line. And now we will be diving into some of the analytics, time series analytics and stuff.
Now, we're moving from the global digital twin of the supply chain ecosystem to the factory digital twin, and then we will see individual production line and its machines. Within this factory, we can monitor the production lines remotely and in real time. By clicking on the t-shirt order, we can see where this t-shirt was produced. Let's see how the production line performed when the recalled t-shirts were created. Using the production line data, we can compare the performance of this line versus the other lines at the same time. We can see the humidity levels were very high, and this might be the reason the t-shirts were recalled. The quality chart shows the historical performance of all of the lines during the given time this order was taking place. It is very apparent the quality issue has been caused by the high humidity. Now, let's see the quality prediction, which in this.
So now if you click on the predict, this is where AI will come in and predict that what will happen if the humidity continues to be at high level, what will be the issues you will be facing, right? So as you can see, historic analysis, time series analysis, future analytics, so many different things you will be able to go back into the time and see, or go into the future and predict.
This case indicates quality will continue to be affected. With this, we need to take immediate action to stop sending below quality product to the warehouses and the retailers. With the digital twin of the overall supply chain in place, now we can see the retailers and orders impacted by this particular factory. The retailer store in Europe has about 10,000 in impacted inventory, and the store in California has about 9,000. As the company can't afford to have any more shipments recalled, we're going to reroute orders from this factory to the other factories until the humidity
So
issue.
you can issue remote orders as well, right? So now, as an administrator of this particular factory, or as an operations controller of this factory, I can remotely click on the stop line and stop the operations of that factory. So whenever I'm sending this signal, whatever IoT devices are responsible for stopping or starting the production line will take the appropriate action and stop the production line.
The production line is addressed. Using optimization and simulation, the digital twin can intelligently reroute orders to factories that manufacture the same product and have the capacity to deliver.
So I can do this sort of, route optimization, route rerouting, capacity planning as well. So now, as you can see, when I'm stopping the production line, I have to fulfill my demand. And using the digital twin, I can also then, do this rerouting and capacity planning. So which other factories are able to supply to my retailers, right?
As we could see throughout this example, digital twin makes it possible to reach.
Yeah, so this is what it is. So this is for the demo about, right, connecting each and every part of the ecosystem. So some of the examples on where it was done. One very famous example, and now it is in the public domain. You can go ahead and search about Skittles. So you have these Mars Den, our chocolate manufacturer, right? So they had used digital twin to enable more efficient packaging. So how do you know that how many Skittles should go in each particular packet, right? So using digital twins and vision cameras, they actually optimized and sort of managed their packaging production for Skittles, and it started that as an MVP, and now it is a 50 million project across many of their outlets, and they are now ready to scale. So if you're interested, you can also go and see like ABN Bev video. That's a beautiful video of Skittles, how digital twin actually helped them achieve the factory of the future, right? So yeah, so that's all for from my side. Thank you so much. And if you have any questions on digital twin or anything else, I'll be happy to take. Thank you guys. Thank you so much.